welcome to this seminar of hydrodemolition. Hydrodemolition is a technology to remove concrete with high pressure water, and is today the most advanced technology to remove damaged concrete with high pressure water without causing damage to the remaining structure. And that's probably the key, that we keep the remaining structure intact. It's myself, Lars Nilsson, and Patrik Andersson from AQUAJET that will hold this seminar, and we will split it in different parts. The history of hydrodemolition. It's not an old technology. It started in the middle of the 80s. It was mainly here in Sweden when the Swedish National Road Administration made a statement in the early 80s. We can't afford to use jackhammers to remove concrete on our bridges as they destroy the remaining structure. That was the message. And that led to that they formed a group, and the group was a contractor, NCC, and a producer, Atlas Copco, and the criteria was set by Swedish National Road Administration, and basically it was to set no damage to the remaining structure. Simultaneously, two guys, owners of Karlstad Industrisanering, did also during this period produce a robot, and they evaluate the possibility to remove concrete with high pressure weight. So it went kind of parallel. And this collaboration with SNR and these two guys, it led to that two robots were produced. It became the CONJET. Atlas Copco produced the CONJET robot, and it became the CONJET robot. And it's sold today by CONJET. Karlstad Industrisanering produced the hydrodemolition robot that became the AquaCutter, and today produced and sold by AQUAJET Systems. It was in 1984 when they did some tests on a bridge outside Stockholm. You see the picture all the way to the left. And it was just manually were they stepping it, and a hydraulic cylinder was turning the jet back and forth over the surface. That was the start. And they start checking if there were cracks, how the surface was, did they remove the bad and left the good? There were several questions. All the way that continued, and they found, if we take the second picture, that it removed the bad and left the good. You can see it's removed in stairs. The bottom part to the right is 40 megapascal concrete, and the left side is 20 megapascal. So they could, with the pressure, go over and remove. The reinforcement had been cut out, so that's not there anymore. Then we have the robot from AquaCutter and the robot from CONJET as of today. 2008, European norm 1504 was rectified by all European countries. And they did not specify that we should use hydrodemolition. They specified that the bonding between all the new concrete should achieve a certain strength. And that strength is not obtainable with jackhammers. Now we leave over to Patrik.
So where do we find the problems and the need? There are many applications, and the most common are in different areas where you find, for example, airports, where you have the runways and also the structures at the airports. Chimneys, renovation of different structural parts there. Parking garages, could be floor, ceiling, walls, other pile structures that need to be renovated. In tunnels in all kinds of shapes, square, round, oval, everything is possible. And of course, berth and piers, where you can, when you have a need of renovation, not only on the top, but on the sides and also under the piers. Diaphragm walls in petrochemical plants, where you need to, when you have large deteriorated concrete parts in all the silos, for instance, and they need to be updated and refurbished. The same thing with wastewater plants. Bridges, where you have especially the bridge joints that due to all the massive traffic on the bridges. Hydropower plants, for example, the skids, where you have all the water that wears a lot with the friction on the concrete. Pillars and piles for all kinds of structures. And of course, buildings. And nuclear, when it comes to cooling towers, cooling channels, and so on. Actually, nuclear is one of those parts that you're not allowed to have any kind of vibration at all in the structure. And roads, for widening roads, for example, is one application of several on the roads. What do we want to say with this? Yes, it's that all concrete structures need maintenance and refurbishment, and a typical repair with percussion method will last 10 to 25 years. And how can we extend that life length? The use of hydrodemolition will extend the life length of the structure and decrease the number of repair over time. And what more do we have in the concrete that causes structural problems? Yes, we have the salt and the chloride, the carbonation, reinforcement corrosion, frost, fire, alkali-silica reaction, and the use of jackhammers. Here we have some different concrete damages with some more close-up here, where you see how the structure is slowly falling apart. Also here you see the rebars is exposed and getting rusty. So it's very common. This is how it looks when it's about ready to get renovated. And of course, with fire, it's also the same thing with the concrete, that you need to remove the bed and put on new concrete. So back to you, Lars.
Thank you. So how is the hydrodemolition? How does it work? What makes it remove the concrete with high pressure water? Actually, the high pressure jets, when it enters the structure, it uses the permeability in the concrete. And with the speed over the surface, it comes to a certain depth. And when the pressure inside the concrete exceeds the tensile strength of the concrete, then will the concrete be removed. And it will be removed from the same way the jet came in, because that's the easy way out. And it won't cause any damage to the remaining structure, as it will go up out of the concrete. Or if you work under up, so you go down, but it's from the surface where the jet enters, that is. When jackhammer is used, it is the compressive strength you have to overcome. And that means that you have to initiate the crack in order to remove the concrete. And when the crack is there, you have a damage to the structure, and you will have problem to get a good bonding. We spoke about hydrodemolition, and hydrodemolition was a defined word. And hydrodemolition works on the quality depth principle. Poor concrete is removed selectively down to a preset quality level, the good concrete. So it actually, at a certain pressure range, takes away the bad and leaves the good. And it provides absolutely no micro cracks in the remaining structure. If there is looks like it is a crack, which can happen, then it's a structural crack that is there before hydro was applied. Then it will open it up. And then it should be opened up to eliminate it. Rough surface, it creates a rough surface. So that helps for the bonding as well. And selectivity, again, it takes away the bad and leaves the good. So not only the bad is removed, it means that you optimize the amount of concrete that's going to be poured back. Here we can see a thin slice. The thin slice shows that there are cracks when you use jackhammers in the remaining structure. Here is the surface. And here's the surface for hydrodemolition, and there are no cracks at all. And here there are even cracks in the ballast stone, which you can see here is a ballast stone. The hydrodemolition in the 80s, we were able to create about 1,000, 1,200 bar pressure. Today, we can reach up to 3,000, 4,000 PS bar pressure. And we have actually gone from 1,000 to 4,000 and in piston pumps, which are mostly used. And that is around 15,000 to some 50,000 PSI. Nowadays, hydrodemolition is often used in 1,000 to 1,500 bar pressure, or some are using 2,000 to 3,000. These are, and we call that hydromilling. And we're using these words to define them. Hydrodemolition is actually used between 1,000 and 1,600 bar. It's a robotic process. It means that the jet is moving over the surface at the constant speed and pressure. Hydromilling, it's a non-selective removal, or you can express it controlled depth removal, because it goes down to rather even depth, so as it can't feel the selectivity, as selectivity declines with increased pressure. And it's still a robotic process with a constant speed and pressure over the surface. So it works pretty much the same as hydrodemolition and hydromilling, but at different pressure range. Water jetting, that's a manual operation, and it's non-selective. And most of the time is around 2,000 to 3,000 bar, but we should pay attention that no more than 25 kilo, 250 Newton reaction force is allowed when an operator is used, not to avoid causing accident. Here we have a picture showing hydrodemolition, and we can see it's the pressure range I told you, around 1,000, 1,500, low pressure in relative terms. It takes selectively. We can see the sides and the bottom is rough. So it follows the quality of the concrete. And poor concrete will be removed and the sound will remain. Next picture shows hydromilling. We can see that the high pressure around 2,000 to 3,000. It has more of a cutting effect on the concrete. The walls are more even, the bottom saw also more even. Still, it takes away, clean the rebar, as both methods would do, hydrodemolition and hydrodrilling. And it will remove, the system will remove the jet down to a specific depth, what you have set the parameters to do, regardless of the strength or quality. So it kind of milling. It looks like more a milling procedure. If we look at jackhammer and hydrodemolition, this is a test done on the same bridge. I think it was around 15, 16 cores. And on the jackhammers, several were damaged before it came to laboratory. For the hydrodemolition, one was damaged. And they achieved different, when they do the pull-off test, they achieved different strength. And the average for the jackhammers were 0.94, and for hydrodemolition, 2.33 megapascal. So we can see that after the concrete is removed and new concrete is poured back and you do the test, you have achieved a better result, more than twice, many times, 2.5 times better. So conclusion is hydrodemolition gets a far superior bonding. The advantage is increased productivity, low or non-impact on the structure, superior bonding by far, cleans the reinforcement, no rust or scale is left, safety and less labor, extend the life of the structure, cuts the cost for maintenance over time, less interference in the infrastructure. Over to you, Patrik.
So when it comes to safety, hydrodemolition does not create what we call white fingers. And hydrodemolition robot is remotely operated, so you don't have to be where the action is happening, and it's autonomous, which means it's less people involved in a process. And when you have less people, it will be less accidents and less noise and no vibrations. So back to you again, Lars.
Environmentally, is it of course better? The use of water sort of binds the dust and prevent silica dust to be exposed to the operator. Concrete wastewater is a problem, but it's been taken care of more and more today. It wasn't from the beginning, but today people are taking care of it and separate the slurry and drain the water or recycle it. Less noise and pollution, and speed. It's less time on each side. They can go in and out very fast. So less disturbance. Here we can see concrete wastewater, it's an environmental problem. And the wastewater cannot, but clean water can be drained into local sewage. There are some regulation that has to be considered to adjust the pH, but it can be after it's separated from the slurry. Here we see a bottle, and its suspended material is around 2,000 to 4,000 milligrams per liter before it's treated. And after it's treated is less than 100 milligram per liter, or if you go and recycle it, it's going down even further. 100 milligram is the level to drain. So it should have been maybe a third bottle, but that's clean, same as you drink almost. The concrete wastewater plant, if I should say, concrete and water can be separated, as I said, or recycled. Here we see the Eco Cleaner from AquaCutter. It's a system with lamels that can clean the water in order to recycle it. Here we have from CONJET a separation unit, a smaller unit that can separate the concrete and get it down to a level where you can drain it into sewage after treated it, the pH value. So it's two ways to go. Over to you, Patrik.
So comparing with other methods, hydrodemolition compared to manual concrete renovation methods prolongs the structure and the total lifetime up to 4 times. Hydrodemolition is 100% free from vibrations, and that's not only good for the operator, it's also outstanding for the surrounding structure. Hydrodemolition only requires 1/8 of a regular workforce. The remaining workforce can, for that reason, be used at another work site. So,
that's probably all. It was AQUAJET, Patrik,
yep.
and CONJET, myself, and it's European Water Jet Institute that have arranged this seminar to happen. Thank you.
Thank you.